delighted to be here and very honored to be able to part of the celebrations, and I also want to thank and congratulate to the whole team of people who are working at Cidacs. I mean, what Mauricio and his team have achieved here, I think, is really incredible, and I was privileged yesterday to hear all the different presentations of many of the different projects that are happening here, and enjoyed tremendously, learned a lot, and I really want to congratulate you for the fantastic work that you do, and I hope that it's going to become bigger and kind of keep improving and getting more and more recognized for its significance in years to come. So I'm also very sorry for the English. Unfortunately, like my Portuguese, I can understand it, so if you want to ask questions in Portuguese, I think I can pick them up. But yeah, you're going to have to suffer through my accented English for this presentation. So what I want to do today is to think a little bit about some of the challenges we're seeing now in relating to the use of big data generally in research. I want to tell you something about what my group at the Exeter Center for the Study of the Life Sciences has been doing and the kind of research we've been doing for the last few years in this respect. Then I want to talk about some of the lessons learned from this work in a more general sense, and I'm hoping to conclude with a few of the lessons learned more specifically for the case of health-related data, which of course are a very, very diverse type of data. So, first of all, you're going to be very familiar with this kind of representation of big data. There's a lot of discussion around all the different V's that are associated to the definition of big data. I suppose one of the characteristics of the work I've been trying to push in this area is to just move away from this representation. I don't think it's particularly helpful. I mean, big data in different areas will have some of these characteristics, not all of them. But what I think is really very important when we're thinking about big data is to think about the mobility of data. The fact that really we wouldn't have big data unless we actually were able to share them, mobilize them, and repurpose this data and reaggregate them in a variety of different ways. So, of course, this is what the FAIR principles that Mauricio already introduced, I don't have to spend any time on this, are really trying to do, to try to make sure that data are, to some extent, disseminated in ways that are socially responsible and also responsible in terms of the scientific use that is made of this data, and it's exactly what Cidacs really is devoted to doing. So again, I'm really delighted to be able to talk to experts in the field like this. Now, the work I've been doing is to really try and think about the challenges that working on big and fair and sometimes open data actually can bring. And there's lots of discussions on this, but I think three things that people really do agree on is the fact that, first of all, changes that are happening in terms of how do we repurpose the research system to be able to take advantage of these vast digital resources which are data now is really affecting a global change in science. It affects science in general. It cannot be something that only works at the national level. I think the wonderful collaborations that this group has internationally demonstrate that. This is something that has to happen internationally and certainly goes beyond and sometimes subverts the boundaries that we already have. Secondly, it has a systemic reach. Every single phase of research is affected by these kinds of changes, and it goes from the design of the research you want to do, all the way from the ways in which people publish and disseminate their work. But, despite being global, despite being systemic, the ways in which we have to think about the challenges of big data need to be local, right? Because each data type and each research question that you're confronting has very particular characteristics, and again, I think that's something that really is really, one of the proofs of the wonderful work that's going on in Cidacs is the fact that this insight has really been sitting in the work of Cidacs from the very beginning. Now, I've been very involved in some of the big European efforts to try and think about what implications this understanding of big data in general has for the research system. You may have heard of the European Open Science Cloud. This, I think, is probably the most ambitious global effort to try and bring together data from any domain produced by any sort of public or even private enterprise dealing with research in Europe. I'm not going to talk too much about this, but we can come back to this if you're interested in what's going on there. And generally, one of the things that we've been seeing very strongly, and is really the focus of my work, is the importance of these figures that are very often not very well acknowledged in the scientific research system, partly because this idea of what a data scientist really is relatively new, is getting reformed anyhow these days, but are really essential to fair data and to data linkage and aggregation, which are the figures of data curators and data infrastructures. So the main contentions, if you want, behind my work are the fact that making big data fair requires, first of all, the coordination and interoperability of diverse data resources. They have to be able to talk with each other, you have to be able to consult them as a body of knowledge. You have to then be able to make the data mobile and useful as evidence across many different sites, which is extremely challenging in many ways. The data infrastructures that facilitate this need to be trustworthy, also an extremely challenging demand. And of course they need to be secure, and they need to be user-oriented. And of course it's very important to ensure that data handling and its implications is actually fair to the people on which data actually are, to the people who are involved in this kind of work, and to the implications of this work, specifically in the case of Cidacs, for public health. And again, this is very difficult and important, partly because despite this acronym, FAIR principles, the idea of what it means to have data sharing that's actually responsible, socially responsible, and fair to society is not part of the principles. Right? So there's lots of work that actually people are working on this, so it's being very acknowledged, this problem. But still, it's something that there's still a tendency to externalize this kind of idea from the world of big data, which I think is really problematic because in fact it's at its very core. And again, it's something that Cidacs has been doing really, really well. So, what are the big challenges to realizing this kind of potential? Very briefly, I'll go through some of the results we have also from other research going on, particularly in Europe. One is the fact that we've been lots of research in Europe about how much do researchers that work in very big institutions with amazing training programs that are supposed to be the cutting edge of the world, how are these people actually able, do they have the knowledge, do they have the understanding that is needed to share data in these particular ways? And actually this was a research that was conducted by the European Commission a couple of years ago, asking people whether they've even heard, just heard the name, right? Not understand what it is, but heard the name of some of the biggest European projects which are involved in fair data and data sharing, which actually have received millions and millions of funding. They provide amazing tools, all freely available online, to be able to train people, train researchers on how actually to do this kind of work. And as you can see here, the number of people that actually have even heard of some of these things, one of them is the European Open Science Cloud, which is supposed to be the place where everybody in Europe puts their data, is incredibly low. If the question about whether they know what they are and how to use them, this will go under 5%. Right? So that's the situation. We have stuff, we have training materials, we have knowledge in this area by now, but nobody really was actually working on the field seems to know about it. The other problem is that to actually make data fair requires an incredible and ever-expanding set of skills and competencies, which really, I would argue, are not something that every researcher that's working on the field can master. Which is why now we're looking at complex interdisciplinary teams which are approaching these kinds of issues. So this was, sorry if you don't see the data, actually it doesn't really matter. This was a research that we've done with some of the main people working on data linkage and repurposing in the plant science area and agricultural science. And all of us have been working in this area for between 15 and 20 years. We got together and we produced this, which is, oh sorry. Which is just a typology, just types. It's not even linking the specific, listing the specific resources. Just types of data repositories, archives, and curation facilities that people really should know about if they want to properly think about how to disseminate the data that they produce as researchers. And as you can see, even just the typology is extremely complex. There's open logbooks, generic open data repositories, specific databases, data portals, paleontologies, metadata standards, identifiers, informatics standards, data annotation patterns, etc., etc. It's very, very difficult. And all of these, of course, keep changing, they keep getting updated. Very difficult for researchers themselves to keep up with all of this. And of course, there's a lot of confusion, which again has been documented by now empirically by many, many different people doing kind of social science research on these kinds of issues. So huge confusion about what openness and sharing mean in practice. Pretty much everybody that we interviewed, we did lots of studies on this, has replied in a different way when they're interviewed about this. How the openness of data sharing can actually be implemented, what is legal, and for whom. Right? Because usually researchers work for lots of different institutions. Their own institution has some rules. The institutions where their collaborators sit have maybe different rules. The institutions of their international collaborators may have yet more rules. The government has rules, the region has rules. Right? And so it's very difficult for people who are working in this area to actually work out what am I supposed to do, what am I allowed to do, which sets of regulations am I supposed to abide to. Of course, the same goes for what is ethical in this area, and what in fact is being recommended. So one of the big projects, the biggest project that we've carried out in this area, we had several over the years, but the biggest project was a project that was funded by the European Research Council, which is now finished, just literally this month. And what we did there, it was a project that was about the epistemology of the intensive science. So how do we understand this type of science? Is something new? Are we seeing something new methodologically here or not? And the key approach there was to track what we call data journeys. So really try to understand what happens when they travel from the sites in which they're produced to sites in which they're being disseminated, curated, processed, cleaned, right? And then to sites in which they're being repurposed. And we're particularly interested in situations where data dissemination sites, like databases, like curation centers, allow for many different types of repurposing.